All right, so now that we've learned that 10 to the fifth power is 100,000 and 10 squared is 100, and we know that 10 to the negative 3 is 1/1000th, let's just review here now for all of these. It's just going to be 4.08 times 10 to the fifth versus 4.08 times 10 to the negative 3. So friendly reminder that when we see that times 10 to the fifth power, we're going 1, 2, and then 3, 4, 5, we're filling it in. So we should see from the 4.08, it's 1, 2, 3, 4, 5. And if we're multiplying for something times 100,000, we should be in the 400,000s. So this one matches up with D. Now we talked about when we see a negative exponent, that's how many zeros we should see to the left. So if I have a times 10 to the negative 3 here, these are my 3 zeros right here, the 1, 2, 3 zeros, and then the 408. And we can check our math in the calculator. Let me pull up the calculator real quick. There we go. We could still do the 10 to the negative 3, you guys know is 0.001. And if I multiply that times 4.08, this is the answer we get. So again, the shortcut here is just being able to look at the negative 3 and see those 3 zeros to the left. So this one matches up with E. 4.08 times 10 squared is the same as 4.8 times 10 times 100. So we're going to move this over twice, and that's going to be a 4.08, or sorry, 408, which matches up with B. We got that one taken care of. All right, now if we see a negative 1, we should just see one decimal to the left of the number. So 0.408, 0.408. There we go. And if it's 10 to the fourth, again, we should see here if it was 4.08, 1, 2, 3, 4. And 10 to the fourth is 10,000, so 4.08 times 10,000 is going to be in the 40,000, so that one's A. So again, what we're looking at here is just using the exponents as a shortcut so that we don't have to actually multiply anything here or even bother plugging it in the calculator, okay? So let's just see some more examples. First, we're going to look at some examples here with negative exponents, and then we'll explore down here positive exponents, okay? Now we talked again about the negative exponents, and when we see times 10 to the negative fifth, we should see 1, 2, 3, 4, 5 zeros, and there they are, and that's including the 0 point. So if you just want to jot down 0.0000, and you can just count as you write them, 1, 2, 3, 4, 5, and then we have a 6, 1, 4, 8. Now, as you guys are writing that down, I'm just going to show it up above that when we see that 6.148 and we move the decimal back 5, I'm going 1, 2, 3, 4, 5, and that's where my decimal is going to be. And this is filling in with a 0, another 0, another 0, another 0, and there's the 0 point. So you can see the 0 point, and then 1, 2, 3, 4 more after that, and that's 5 total, and that's the 5 total zeros, okay? Now, if we did 3.9024 times 10 to the negative 2, again, that's times 1/100th. So we can just move this decimal back once, twice, and we'll fill in with 1 0. And when we put the 0 point, you can see again, there's the 2 zeros in front of the 3902. And let me make sure I got a 4 there. And if you see 4 times 1/1,000,000th, instead of having to actually bust that out in the calculator, again, take that 4.0 and we're just going to go back 6, 1, 2, 3, 4, 5, 6. And when we fill that in, we've got 1, 2, 3, 4, 5 zeros, but then the 0 point. So there's my 1, 2, 3, 4, 5, 6 zeros total. Okay. Now, if we've got some numbers already here in standard form and we want to write them in scientific notation, notice that you just have one little 0 here. And so this is going to be a times 10 to the negative 1. Let's go ahead and take care of that part. This one, we see 3 zeros, so this one in scientific notation would be a times 10 to the negative 3. And this one, we're going to have something times 10 to the negative 3 as well. And now let's just see what it is times those numbers. So if I move this right here, there's that one spot, so there's the 1.463. This one we said was the 1, 2 from there. And then we got to go to a third spot. There's the 2.9 times 10 to the negative 3 we already said. And this one we already said is going to be 3 spots. So 1, 2, 3. So that's a 4.01 times 10 to the negative 3. So the negative exponents and seeing the zeros is really easy to just kind of count those. And now's a chance to just pause and practice. Just pause the video and practice these 1, 2, 3, 4 problems to see how you're doing. And when you hit play, I'll remove those gray boxes so you can check. Okay, so go ahead and hit pause and try these 4 right now. All right, let's see how you did here. So for the 5.94 times 10 to the negative 2, there's the 594. And we should see 2 zeros, 0.0594. And when we see 2 times 10 to the negative 3, it should be a 0.002. And friendly reminder there, I'll show you again in the calculator, we're doing 2 times 1,000th. And that's the answer that we're getting right there in blue. But we're just trying to avoid the calculator, okay? Here, this is going to be the 2, and then we have 1, 2, 3, 4, so times 10 to the negative 4, we have 4 zeros right there with the decimal. And again, 0 point, so there's only 1 0 there, so times 10 to the negative 1. 4.3 times 10 to the negative 1. All right, now let's practice here with some positive exponents, all right? Now this is a little bit tricky when we see a number like 68,985. So we're going to have to pretend like we don't see a decimal right now in the thing, and that's one thing that throws students off. But I could put like a 0.00 here and make it look like money. So now I have a decimal. And we can just count and see 1, 2, 3, 4. It's going to have to move 4 times, so I'm going to put a 10 to the 4th right here. And that's a 6.8985. So 6.8985. And I'm just going to erase those little zeros there so it doesn't look so busy. And to check, you can kind of say, okay, so if I had this number right here times 10 to the 4th, I would move it 1, 2, 3, 4 times to the right, and that's exactly the number I see, so we know we did everything right, okay? All right, so same concept here. There's one little typo. It looks like this should also include a 0 because this is supposed to be 320 million. So we've got 320 million here, and double check that you put a 0 there for me, okay? And now if I make it look like money, I have a decimal. So this decimal is going to move once, twice, 3, 4, 5, 6, 7, 8. So we've got 3.2 times 10 to the 8th. And let me just show you guys that, like, if you have numbers in all the spots, of course you have to write out all the numbers. But when these are just a bunch of zeros, I don't have to write 3.20000. I can just write 3.2. Because you guys know that 3.2 is the same thing as seeing 3.20, which is the same thing as seeing 3.200. So we don't have to write all those zeros for that part, okay? So anytime it's just a bunch of zeros, it's okay to just put 3.2 and then times 10 to the 8th. And for this last one, if we're at 516,257, we're going to go back 1, 2, 3, 4, 5. So this is a 5.16257. We have numbers in all those spots, so we have to write them all out. And this would have been times 10 to the 5th, which is 100,000, to put us in the 500,000s. Okay? Now, if we see the 5.36 times 10 to the 4th, this is back to actually what I think is the easy part here. You just use that exponent and you're going to go 1, 2, 3, 4. And we have to fill in with some zeros here for this to be 53,600. And the more of these you do, you'll kind of make sense of that. You'll be like, all right, this is times 10,000. So 5 something times 10,000 should be in the 50,000s. All right, now this one is a unique example where we're only going to have to move the decimal over 2 times. So I'm going to move this decimal to the right twice. And now I have an 800.021. And that's okay, y'all. Sometimes when you're moving this and it tells you to move it times 10 squared and you move it over twice, you might still have a decimal here in the answer. Notice when we did 5.36 times 10,000, we just had like a really big number, no decimal. But when we move it, sometimes if there's still numbers left over, you might have a decimal in your answer like that. So 800.021 is the final answer for that one in blue. And now here, if we have a 2532 times 10 cubed, so we're just going to move it to the right 3 times. And if 10 cubed is only 1,000, it makes sense that this would be 2,532. And this time we happen to move it the exact number of spaces, so we don't have any decimal stuff left over, and we don't have to fill in with any zeros. This was the exact number, so 2,532. So here we have another pause in practice. I have 4 more problems here with positive exponents and big numbers. If you guys want to just try practicing those real quick, and when you hit play, I can reveal those boxes. All right, so let's see how you're doing here with this. All right, we have 5.94 times 10 squared, so 5.94 times 100 is 594. And 2 times 1,000 would be 2,000. 20,000 here is 2 times 10 to the 4th power, because 2 times 10,000 here is 20,000. And if I had 465 written in scientific notation, that's 4.65 times 10 squared. Now I'm almost done here with the video, but there's one thing that I want to talk about with you guys real quick, and it's kind of the concept of if you were working on something and you tried to hand this into a teacher, the teacher's probably going to tell you that you're not done with that problem because you didn't do something with this fraction. You didn't simplify it or reduce it. So instead of telling me the answer is 4/8, I'm going to be looking for a 1/2 to tell you that you're right. Now you guys know that somebody telling me that the answer is 5/10, well, 5/10 is also the same fraction. And it's like one of those things where it's like, why, like, not why, but like we could have lots of different possible right answers. But when we're putting it on a worksheet, we always reduce it so that we kind of have one right answer that the teacher is going to go over. So like telling me 3/6 is a fraction that is a half is like good to go. You can tell me that that also reduces to, or makes a decimal of 0.5. But the reality is I'm not going to want to see this on a worksheet. We're always going to pick the reduced answer, the 1/2. So now let me kind of flip back over and talk about that in scientific notation. So I want to ask you guys, and I'm just going to use a highlighter actually to do this math, the calculator to do this math, I should say. Sorry about that. But if I have a 423.05, a 423.05 times 100 is 42,305. And you can confirm that because if I took this number and I moved the decimal over twice, like it says to do, I'm at 42,305. So go ahead and jot that number in that little blank. All right, let's recalibrate. What if I had this problem instead? What if you saw 42.305? So let's reset. Let's do 42.305. And this one is times 1,000. I get the exact same answer. So it's a lot like saying if I did 5 divided by 10, I get the exact same answer as 3 divided by 6, as 4 divided by 8. All of these are a 0.5. We get the same answer. But if we're looking at this page right here and we want to talk about which one's right, we would go with this reduced version. This one's kind of the one that we're going to consider right. So back over here to this concept, if this 423 number times 100 and this 42 number times 1,000 give us the same thing, it's like, how do we actually write 42,305 in scientific notation? The question is like, which one of these is going to be the right way to write it for this number that we have boxed in blue? So there's kind of like a rule that we have here, kind of like in grammar classes, we have like you got to capitalize at the beginning of the sentence. There's a rule here that just says the number in the problem has to be between 1 and 10. So again, we could do the 423, just stick with me on this, the 423.05. This one is 42.305. See how these are not numbers between 1 and 10? They're not numbers between 1 and 10. But if I move the decimal over one more spot, now I've created a number between 1 and 10. And so this right here, this would move 1, 2, 3, 4 times to make the number that we're talking about. So this is the correct way to write it in scientific notation. Even though this times 10 squared and this times 10 cubed give us the same answer, this one's the one that we're going to consider right because it has a number between 1 and 10. 4.2, that number right there, that's a number between 1 and 10. 400 is not between it, 42 is not between it, and so this is the one that we're going to jot down as the correct way to write it. So 4.2305 times 10 to the 4th is the right way in scientific notation to write the number 42,305, which is this guy right here. Okay. So the last part of this video for today, y'all, is to just actually try to identify real quick, if I give you these 5 numbers, which of these are actually correctly written in scientific notation, meaning you see a number between 1 and 10 times the 10 to the negative 3 or 10 to the 4th or whatever. So is this right here a number between 1 and 10? Is 5 between 1 and 10? It sure is, so this one works. Is this number between 1 and 10? It sure is. 2 is definitely between 1 and 10. Now, is 41.9 sine 5? Is that between 1 and 10? No. 41 is not between 1 and 10, so we're not going to pick this one. Now, is 7 point something between 1 and 10? It sure is, so this one is correctly written in scientific notation. And is 0.532 between 1 and 10? No, it is not. So this is not correctly written in scientific notation. So the 3 that we're going to pick are already circled. And that concludes today's video. You're going to just do some practice now on your own. Thank you for watching.